Okay, so let's talk about each of these really cool phenomena that we saw in this article. So the first one here is the water strider. So you can see he's balancing on the surface tension. And we've all heard of surface tension and we all are aware that it's there. But how come it's there? Like, what is this bug standing on? So you know from the video that we watched before that water makes hydrogen bonds between it, and it makes the water sticky, right? Cohesive and adhesive. And so the bug is literally standing on those hydrogen bonds. So alone, a hydrogen bond is really weak, but together, hydrogen bonds can be really, really strong. Like, think about jumping off of a cliff, right, into the water, and it seems like, holy cow, you just hit cement. That's because you're hitting all those hydrogen bonds. So it can actually be quite hard, and enough for a bug to walk on it. Wasn't this seed so cool? So in this case, the tails of these seeds attract water. And so as the seed during the day, when it's moist, it gathers water and it straightens out. And then as it dries out at night and cools down, it coils back up. And it just does this over and over again. It actually drills it right into the ground, which is really cool. This one, the floating fern, this gives it an edge, right? So we've got these little hairs that are sitting on the outside of the leaves. And if you read from the article, the hairs are actually hydrophobic here in the shaft, but hydrophilic on the tip. So they attract the water here, but repel the water here, so it allows them to trap this air bubble there, which allows the leaves to float and outcompete other plants that might be sinking into the water. Public restrooms. So this is disgusting, right? So when you flush a toilet in any restroom, but especially a high flush toilet, it aerosolizes some of that water that's in the bowl, right? And it leaves the water's surface and gets into the air, and then you breathe it in. Gross, right? And the more cleaning products that are being used, like especially in a public restroom where it's being cleaned way more often than my restroom at home, the cleaning products actually decrease the surface tension. They interrupt those hydrogen bonds, and so it's even more likely to aerosolize. So what can you learn from this? Well, a couple things. Number one, flush and run, baby. Flush and run. Don't breathe. And number two, this is what we do at my house, right? Don't ever flush something that's in the toilet like vomit, right? So when my kids get the stomach flu and they throw up into the toilet, there's a whole bunch of viral load, viruses in that toilet. And if you flush it, they're very, very likely to aerosolize, and then you suck them in, and then everybody in your house gets sick. And so what I do, as gross as it sounds, when somebody throws up in the toilet, I go get the bleach and I pour bleach into the toilet and I close the lid and I close the bathroom and I walk away for 5 minutes. That'll kill all of the viruses in the water so that when you flush, you're not aerosolizing that into the air. So just kind of a little tip for you. This one, how does rain spread disease? Right, so it talked about in the article that because the waxiness of the leaves is hydrophobic, it doesn't allow the water to absorb. So the water collects on the leaves, and then viruses from the plant can collect in that water. And then when the rain hits that leaf, it springs that water into the air, and then it spreads to other plants. All right, and lastly, how do large bodies of water moderate temperature? So we know from the video that we watched before that water has a very high specific heat. What does that mean? Well, it means that it takes a whole lot of energy to raise the temperature or lower the temperature, energy transfer. And that's because, again, of these hydrogen bonds. In order to heat water up, you've got to break a whole bunch of hydrogen bonds. And in order to cool it down, you have to form a whole bunch of hydrogen bonds. And that makes it change temperatures more slowly. So if you live by a large body of water and there's a ton of water in the air, like San Diego, for instance, then it's going to make the air temperature change its temperature more slowly as well. So it moderates that temperature.